Today I'm going to be continuing on with definite integrals. So the first thing we want to go back through is the definitions of two special definite integrals. The first one, or for both of them, we need to know that if f is continuous on the closed interval and f is integratable on the closed interval, then we can define an integral that goes from a to a as having an area of 0. Also, the other one we've talked about is from b to a. If we want to flip-flop those bounds, we can put a negative out front. The second thing we want to go back through is how if we have some different bounds, we can actually break those up and we can split them into two separate bounds and add them together. So if c is in between a and b or vice versa, or however, we can actually break those up so we can go from a to c and then c to b and then add those integrals together. The next thing we want to talk about again is bringing or having that coefficient out front and bringing it out front. And when we bring it out front, we'll just multiply it through at the end. The last thing we want to talk about is if we have two different functions, whether they're added or subtracted, we can break those up into two separate integrals and solve each of those. All of these things we saw in the last video. This problem's what we have here is I'm given that the integral from 0 to 3 of f of x dx is 4, and from 3 to 6 f of x dx is negative 1. We're supposed to find the area from 0 to 6. So what I notice is I actually have from 0 to 6 if I just combine them. So I'm going to write this out, 0 to 3 of f of x, plus, I should put the dx in there, from 3 to 6 f of x dx. Well, I know this to be 4 from the information given, and I know this to be negative 1 from the information given, so that means my combined area would be 3. The next one, if I look here at what bounds I'm given, it's just those being flip-flopped. So what I'll do is I'll put a negative out front using those rules that we just went back through, flip-flop my integration, or my bounds, and I end up with the answer of negative 1. Well, negative 1 is a 1. So my total area underneath the curve is 1. Moving on here, the next problem, I still have the same information that's given. I just have some different bounds. So here I have the bounds 3 to 3. Well, from 3 to 3, I know that special definition to be equal to 0. The next one has the constant, so we can bring the constant out front. Write it as negative 5 from 3 to 6 f of x dx. Well, that gives me negative 5 times whatever this area underneath the curve is, which is negative 1. And then negative 5 times negative 1 happens to be 5. So the area underneath the curve would be 5. We have a couple more of these. This time I have some different information that's given. I'm given from negative 1 to 1, the area underneath the curve is 0, and from 0 to 1, the area underneath the curve is 5. If I want to find the area from negative 1 to 0, I could do that by taking this area from negative 1 to 1 and subtracting, I didn't mean to write it equals 0, and subtracting off the area from 0 to 1 of f of x dx. We know this area to be 0 minus this area happens to be 5, so we get the combined area to be negative 5 for that problem. This one right here I have from 0 to 1, I'm given that piece of information, that's 5, minus from negative 1 to 0. I just found that information, it is negative 5. So that means my combined total area would be 10 for this part.